This video is about my Excel spreadsheet for balancing a single cylinder crank. This is the spreadsheet, and what it does is graph the combination of inertia and centrifugal forces every 15 degrees of crank movement. And this is the graph right here in this case. This is a reference graph right here. If from zero, each of these forces, outward forces, are equal all the way around 360 degrees. This is no simple calculator. It takes all the forces. Let me read some of them to you. Kinetic force angle from horizontal, radius of arc, velocity, centrifugal force, pounds per foot of kinetic energy, vertical force, and horizontal force. All of those are totaled together for every 15 degrees. And that has to be done because of this. It's called a connecting rod. If this right here was of some super metal that weighed nothing, there might be a simple formula to do a crank balance. But from here all the way to the other neck, it has an odd movement because this is fully vertical and just vertical, and this end right here is completely circular. But you have a combination of the two right here, and that makes it more complex. Probably the strongest inertial force you have is when the piston reaches top dead center and it's changing direction. So you have an inertial force that's upward, which is countered by the downward centrifugal force of the crank due to the two or more holes on this side right here. My calculator can also compensate for sculpted out areas in cranks and allow different substances to be the filler for holes. This right here is the YouTube video of mine that shows you how to enter in a virtual set of holes to compensate for these sculpted out areas. This right here is to help you get the right calculated weight for the balance shaft on engines that do have that, which would be the big bore usually. This right here is about adding in the weight loss for holes and slots drilled in the connecting rod. This right here is the page that gives the instructions on how to use it, which is detailed. Actually, this is the intro page to the instructions. This is the instruction page. This right here tells each measurement that you make, whether or not it's a measurement or figuring out the weight. And you do have to have a little digital nailing scale to weigh these things on to get the grams for each one. A calculator like this is essential because of the connecting rod. You can't use the balance factor because it really is not a method to determine what the balance hole change should be. It's really just a method of conveying to someone else with the same crank what you did to yours. It's not a method for figuring out what you need to do. So so you enter in all the details that are described on the instructions page. And these columns right here are for the hole sets. For instance, these two are the same distance away from this center line. So even though there's 4 of them, they're considered one set. So you have 4 right here. And the filler is air. So number 1 is air. Number 2 is plastic. 3 is aluminum. 4 is brass. 5 is lead. And if you have some other substance, you can enter the density right here. So then you get the diameter, the length of each hole, the distance from the center of the hole to the center of the crank, and the degrees from this center line right here, from the crank center to the conrod pin center. So these are 24.5 degrees off, which goes right here. If you do holes on the opposite side, it's 180 degrees like what you have right here. For each of these RPM going up to the maximum that you state right here, the calculator will graph this and then put it, boil it down to a single balance number right here, and then that number will be graphed right here. And the idea being that the most perfect balance will be right at 1 at top RPM. This is my ride, and it's a small engine, you know, so the smaller the engines, the farther off you can be. This is 9% off, and I can't feel any vibration on it. So I'm going to show you what happens when I erase that. Put 0, which nullifies all this info in this column right here with this set of holes. And it causes an imbalance to be more fore and aft of the engine. This is in line with the cylinder right here. And this is 90 degrees off. So if we click on the macro button right now, it will regraph this and it will show the difference. Now it's going below the 1.0 line. So anything below is too much fore and aft vibration, and anything above is too much vertical vibration. So I'm going to put this back at 2. This right here is the balance, the balancer details after using that calculator at the bottom. When you're doing this, without even looking at any of this, you can look just right here. The closer you get to 1.0, the better off you are. So you can enter in the holes that exist, and then hopefully you have room enough to put another set, or just, you know, change the diameter of existing holes. It's a fantastic calculator. My competitor charges $400. This is $30. So I don't know what else to say. It's great. Try it. You'll like it. Here's other graphs. This is the graph just of the vertical forces. This right here explains what each graph is. So that's it. Thanks for watching.